Hi, I'm Chihiro Nakatani from Toyota Technological Institute, Japan. I will introduce how to learn group activity features through person attribute prediction without group activity label. This paper focuses on group activity. Group activity consists of multiple people and they interact with each other. As shown in this figure, volleyball is one example of group activities. In this volleyball scene, Light team players decided their behavior based on the spiker located in the left side. This seen defined as spike group activity in previous research. In previous research, the group activities are recognized into predefined group activity classes, as shown in this previous slide. The variation of group activities are large due to there are a large number of people and interaction between these people. Therefore, finally recognizing group activities are difficult in previous research scheme. Different from the previous scheme, we focus on how to learn group activity features without group activity labels. Our group activity features can be used for many applications as follows. To learn group activity features, our network learn it through person attribute prediction instead of using group activity labels. We propose to employ person action and appearance features in our method to learn group activity features. This figure shows one example of our learning strategy. Our group activity feature is learn to predict the attribute of person enclosed by purple rectangle. For predicting the attribute of the person, we employ health location as a condition. So the person attribute prediction, a group activity feature, is learned to represent the context of scene. Let's move to on the experimental result. Group activity feature learned in previous and our method are shown in this figure. Each point denotes each group activity feature visualized by TSNA. And the color is corresponding to the group activity label. The results also show that our group activity feature has learned well through our method. Next, I'll talk about the details of our group activity feature. This figure shows that data points with the same group activity labels are divided into sub-activities. For example, help paths indicated by the magenta data points are divided into two clusters. While the cluster enclosed by the orange rectangle represents a path where the person is receiving a ball from the opposite spike. The other cluster enclosed by the light blue rectangle represents a path where the person is receiving a ball from the opposite server. As shown in this example, our group activity features are learned well enough to represent visually subtle but important differences that are not represented in the manually defined group activity classes. In conclusion, our method learns group activity features through person-attribute prediction without group activity labels. To predict the attribute of each person, we propose location-guided group activity feature learning. Experimental results show that our group activity features are learned well enough to represent visually subtle but important differences. Thank you for your watching.